So putting everything together, we have been using the GCC and the linking commands separately. But then this is even without using the makefile. We can have all these 4 steps combined into one, and it is written like this: arm none abi gcc minus I dot minus I include. That is, the include paths are fed into the compiler, and then you have minus g minus o0, and Cortex M4 M thumb, no start files, so on and so forth, and then the source files, and minus t build example.ld minus o, and then the dot out file. Now you will see that we have not used many intermediate file names here. For example, build example main.o and core initialization stm32f411xe.o. All these intermediate file names have not been used in this command, but they are internally generated, and it linker compiler and the linker works exactly in this order. That is, the LD is actually used in this command, and everything works as these 4 steps. It's just that this is a short way of writing it. And when we automate our build using makefile, we are going to follow this one. We're going to for the final stages of. So in the previous demos, we saw that we had written the whole command in the makefiles, but in the final makefile, because we have learned so much more, we have learned about vpath, we have learned about variables and so on, we can actually write the command like this, and then quite a few shortcuts to make our lives easy. So this command that we saw previously actually boils down to this in the makefile. Okay. So and how does that happen? So let us go through this here, and we will of course see it separately in the makefile also when we see the demo. But then this is the command that we saw previously. So this is the command that we have been using previously, that we saw, the combined command. Only 2 things have been added here. That is the wl map output.map and build example.out, which we did not put here. That was a small mistake from my end. So this would need to have this one as well, wl map output.map and build example.out. So this is the full combined command to create the dot out file. This is not going up to the binary stage, and this one comes down to this in the makefile script. Now, what is the meaning of this if we have to expand this? So let us try and understand how this command comes down to this one in the makefile. So let's go through the makefile stages one by one. So cc is gcc, that's a variable we declare. Build prefix we saw previously, arm none abi. Build command is again build prefix dot cc, that so build command comes to arm none abi gcc. Then you have, this was just for temporarily checking something. So here in this makefile, we have the minus g option or the debug option removed, but you could have the gcc options minus g put in here. GCC options is again minus O0, the Cortex M4 as MCPU, M thumb, no start files, hard float, MCPU V4. So this part is put in the GCC options, as you can see. O0, Cortex M4 thumb, no start files, M hard float, and so on. So up to here, the GCC options have been put into this variable. OBJ copy is the option for generating the binary. Now this one also could have been prefix and cc. So arm none abi obj copy, we could have it. So we could do build prefix and obj copy here with just obj copy, and then we could have done build prefix into $obj copy, and we could have brought this out. That was also possible. OBJ options minus o and binary. So this is the OBJ option to create the binary file. So, and then C flags, it says add prefix minus I to include that dir. So this means add prefix adds a minus I to the include directory paths. that is minus I before the include directory paths. Now we see that some more variables are declared here. For example, include directories, which is dot space include, means the include directory is the same, is at the same, search for the include directories at the same level and also in the include folder. Then you have source directory, which is src, and then source one is, again we have build example main.c, source 2 is startup gcc.c, and so on. Okay, so these are anywhere there, but they are not being utilized, these two variables. Then we have headers, and the headers are core initialization stm32 f411xe.h, and if you have to declare the variables in new lines, it should be space backslash and then the new name. So thus you can beautify the list, so it will be in a single column rather than going out sideways. So you have headers like this, declared like this, and then you have the sources. So here you have a list of all the source files that you have. So we are just using 3 files. If we are using more files, then we'll add the files here, and then the name of the linker script, and then the vpath. So we are using small vpath, %c, look for, so %c dollar source directories means dollar source directory. So source directories are in src. Okay, so for the %.c files, it will look into the source directories, that is src. For dot headers, it will look into the include directories, that is dot and include. So this is the vpath. And then when we do, and then we declare a statement in main like this. So what we do is build example.out is the target file, and then we have sources and headers. Now let's see what happens here. Now $@ is build example.out. So this is the target, this one. Okay, and $caret is the source. So let us expand this command, whatever we have put in here. If we expand this command and it looks like this, we will know that make is actually doing this job. So how is it doing the job? So one thing is, for header files, we have to give -i here. So -i include directories, we have to feed that into C flags anyway, for the compiler to know where the include files are. So if you declare the headers here even, okay, there is no simple way of actually including the headers through these variables, these automatic variables. Okay, so we need to declare the include separately. So that is something that I have seen. If you find a way to do it through the automatic variables, great. So let's expand this. We have $sources and $headers. So $sources are these 3 files, the list of these 3 files, and $headers are these 2 files, right? So build example.out, and it has, imagine that it has put build example main.c core initialization stm32f411xe.c and startup gcc.c. So you see the advantage of having this in a variable. If we change a file here, it will automatically, we don't need to write the list of files here. Anything you change here is going to be taken in here. That is one advantage. And as I said, the headers have to be separately declared in the given into the compiler with the -i option, and these headers are not used actually, even though it comes into comes in here in this automatic variable. We don't do anything with we leave the header part out. So why do we have the headers here? The reason for having the headers here is, if anything changed in the header, it will at least run the build again, because the headers have changed. So for timestamp checking, the list of headers have been put here. But these headers, if they go into the command, they don't do anything. Okay, so that is something that we have to be aware of. The headers are pulled in by the source files. So the source files will have the header mentioned, the dot include headers, and these, the C flags here, that the add prefix is going to, the compiler is actually going to look into this -i dot and -i include, and it is going to pull the header files in for the compilation purposes. So build command. So what is the build command? Build command is arm none eab igcc, right? So build command is arm none eab igcc. We can see it from here. So okay, we can just underline it here, so it's easier rather than writing it below like this. So we have arm none eab igcc. Then we have GCC options. So what is GCC options here? -o mcpu cortex m4 mthumb no start files mhard float. So -o 0 mcpu mthumb no start files mhard float. Okay, and mpfu v4. So can you see this? This part is covered by your GCC options. All right. Then we have C flags. So what is C flags here? Add prefix -i. So add prefix is a command to add -i to your include directories. So include directories is dot and include. So it will be -i dot and -i include. So -i dot and -i include will be this. And then you have this $caret. Now $caret is a bit here, whatever is printed in $caret prints some extra information. For example, it prints the name of the header files, which is not used by the compiler. Nevertheless, let us see what $caret will print. $caret will print build example main.c core initialization, but see the use of vpath here. Here we have named the sources as build example main.c. So build example main.c and then core initialization .c, whatever. You can see this, not writing the whole thing. And then we have startup gcc.c. Okay. So you see, these are just the file names here. Okay. So we have just put the file names in the sources, not the full path. But we know that these files reside in the source directory, startup gcc.c and core initialization stm32f411xe.c. They both reside under the src. But we have not given the full path here. And this is the beauty of the automatic. This is the beauty of the. Of course, this is the beauty of the automatic variables and the vpath. Okay, so what does vpath do here? We have anyway given the source file names. So the vpath searches for these sources. So these .c files, vpath actually searches within the source directories. So source directories are given here, src. Okay. So what vpath does is it searches in the source directories. Okay. And when it finds the file, it puts the right path here, .src something. Okay. So it puts the right path here in the vpath, and since build example main.c is in the main path, okay, we don't need to vpath doesn't search in the we have not asked. So if you see the source directories here, where is it? It is here. We have not put .src, but it still works. We could put dot and src again, so the vpath will search for the src anyway. We should have done that, but nevertheless, so when these file names come in, the automatic variables and mind it, the search happens through the prerequisites. So prerequisites, and then you have the automatic variables, and the search path is this. In a sense, the search goes through like this. It is only through the prerequisites does the search happen. So you cannot just give a vpath reference somewhere and expect it to search for those files. Vpath reference is taken through the prerequisites and the automatic variables, and this is how it happens. You could also try giving dot sources dot headers here instead of the automatic variables, and the effect should be the same. That is, try it out yourself. That is, give the dot sources and dot headers in these places. Put build example dot out and then dot sources and dot headers here, and just see if it still searches through the vpath. Okay. And then we have linker script. So linker script is, so I hope you understand this part. It actually searches for these files, gives the proper path and puts it in here. So it will actually put src dot slash core initialization src slash start of GCC, and this will all be done by Makefile. You don't need to or hard code the path here. So that is one advantage of writing it this way. Then you have the linker script. So linker script is again build example .ld. So similarly, build example .out could also have been parameterized. We've just mentioned it build example .out here, but nevertheless it could be parameterized as well. And then $@ is the build example .out. So -o build example .out. So WL output underscore map. Let us see where it is. Can you see there is a mistake here? At least in this particular, I have not accounted for this in the script. And good in one way, because you will see these are the mistakes that we commit. So this should have been a part of a particular variable here, which we have not. So maybe it could have been a part of the linker script. Okay. So linker script is saying what? Linker script only has the linker file name. So linker command. So there should have been a linker command. Linker command variable here. Did you see that variable is missing? So here we have put it separately. Output map. Okay. This did not have been put here separately. This should have gone into one of the variables, so that this could also have been saved. In the sense, we could have had a linker command here, and it should have gone in there. Okay, so that's a mistake. Even though in the output I have forcefully put it in here, it was better if we had managed to include it in this particular script to write this option here, including the -o. Okay, so this is something that you can correct. So when you write your Makefile, make sure that this is parameterized also. Going further, we just have the script written in full, that is including creation of the binary. So let's have a look at that. So this is the full script, and we have seen most of it now. Okay, and here also we have WL map, output map. This could be put into a parameterized. Now the only change here is the build example.bin output. So build example.out is the prerequisite here. Build example.out is the prerequisite, and arm none ABI obj copy, and then -o binary example.out build example.bin. Now if you see, this is again I have left it as a full blown command here. Okay, this could have been parameterized. So this could have been, so when you write your Makefile script, you could parameterize all of this. Build example.out could be parameterized, and these values could be parameterized. Though this creates the files as it is, it could be parameterized further.